Hello guys, welcome to my channel. Today I'm going to talk about biaxial compression test with Mohr-Coulomb model in Plaxis 2D and Plaxis 3D. So if you want to download this paper, you can check the link in the description, and don't forget to subscribe and hit the notification bell so you won't miss a new video every week. So I'm going to start with Plaxis 2D. First I change the boundary condition, boundary side, and add a borehole. Change this to 1, and I need to create a material. So you can check the property of the material in this paper, and now you can assign the material. Next you need to add line load at the top and also the bottom, sorry, the right side of the soil, but you need to change the direction. Next you can go to mesh, and you can view the mesh result. And for the last part is state construction. So you need to add page number 1 and change the boundary condition. So for X maximum you need to change it to 3, and for the Y min you need to change this to normally fixed, and you need to adjust some setting here. And you need to activate the load as well. And next you need to add another page, change the load here to -10, and you need to check the boundary condition, add the same as page number 1, and you need to change the property here also. Now you need to select a stress point. Okay, now update, and now you can run the analysis. Okay, now you can show the result. So I'm going to create this graph. So for the x-axis it is the principal strain, and for the y-axis it is the principal effective stress. And you need to invert the sign also. So this is the graph, and you can compare with the result in the paper. So for example, this point the stress is 6.47, and you can check with the result here. So this is the effective axial stress when the soil fell. Okay, now this example is finished. I'm going to do it again in Plaxis 3D. It's actually the same. You can see the step here. So I need to add a material. And assign it. Okay, next we need to add two surface load. For next one, it will locate at this side. You need to change the direction also. So this will be minus x. Now you can go to mesh. And you can view the mesh result. Okay, for the last part of this model, you need to add a pace of construction, and you need to change the boundary. So for X max, you need to change this to 3, and for the Z min, you need to change this to normally fixed, and you need to activate the surface load and adjust this setting. Now we need to create another pace, and you can check the boundary condition again to see whether they are correct or not. And you need to change the surface load on the top to -10, and change the setting here. For now, I need to add a stress point. You can select any stress point. Now we can start the calculation. Now you can view the result, and I'm going to create the same curve, the same graph here. So for the x-axis, it is the strain, and for the y-axis, we select the principal effective stress here, change, and select this invert sign option. So this is the graph, and you can check the result here. The stress is 6.47, and you can compare with the result in the paper here. Okay, so this is how you do the test on biaxial compression with the Mohr-Coulomb model. I hope you enjoy this video, and thank you for watching. Don't forget to subscribe and hit the notification bell. So I'll see you guys in my next video.